Hello everyone, welcome to tutorial number 10 in database CSEN 501. In this tutorial we are going to introduce a new topic, which is the normalization. After the previous tutorials, now we are done with the queuing languages. Now we are going to consider the schema we created, which will be mapped into real tables. How can we decide if this schema is good enough? Actually, this can be answered with the normalization theory. What is the purpose of the normalization? Actually, the purpose of the normalization is to achieve a design that is flexible, reduces redundancy, and last but not least, free of update, delete, and insertion anomaly. So now the purpose is to have a schema which is flexible, not redundant, and free of update, deletion, and insertion anomalies. Now, we want to know what is the meaning of anomaly and what is the meaning of update anomaly, insertion, deletion anomaly. What is the update anomaly? Actually, the update anomaly is data inconsistency. Okay? That results from an update. Let's take an example. Assume that we have table employee or relation employee with name, telephone number, and room number. Name is primary key. And now this employee changes their room number. If the telephone number is associated with the room number, then there will be data inconsistency, because in this case the room number will be changed, however the telephone number is not changed. So this happened when we have two attributes that are related to each other and only one of them is updated. This is an update anomaly, which is data inconsistency results from an update. Okay, let's take an example for the insertion anomaly. What is the insertion anomaly? Actually, the insertion anomaly occurs when certain information cannot be inserted because of another attribute. Okay, so this happens when certain info cannot be inserted. Okay, how this can be done in real life? Let's assume that we have a relation employee with SSN, name, age, department name. Okay, the primary key here is the SSN. So, what is the case if we have a new department that is going to open by the end of this month, for example, and we want to insert its information in our database? In this case, we cannot enter a row with the department name because we don't have SSN, which is the primary key of employee. So, in this case, the department cannot be recorded because of the other attribute, which is SSN. Okay, so this is an insertion anomaly. The last type of anomaly is the delete anomaly. Okay, what is the delete anomaly? Actually, it occurs when certain information is lost because of the deletion of other attributes. Okay? Let's take an example. Assume that we have employee with this SSN name, age, and department number. And we decided to fire all the employees. In this case, all the information about the department will be lost because we deleted the whole record. This is the deletion anomaly, when certain info is lost because of the deletion of the other attribute, which is the SSN, the primary key. So again, to recap, the purpose of the normalization theory is to have a schema which is flexible, free of redundancy or reduces redundancy, and free of anomalies. Okay? In order to understand the normal forms, we have to understand these two terms, the functional dependency and the fully functional dependency and the prime attribute. Let's start with the functional dependency. What is a functional dependency? Okay, a relationship between attributes. So the functional dependency, actually it's a relationship between attributes. When we say A implies B, this means that B is functional dependent on A. Okay? Which means that if we stated that B is functional dependent on A, this means that each value of A is associated with exactly one value of B. So in order to decide whether B is functional dependent in A or not, we should check that each value of A is associated with exactly one value of B, which means that the value of A determines uniquely the value of B. Let's take an example. Assume that we have A, B, C. A1, A2, A1, B1, B2, B3, C1, C2, C1. Okay, let's see the relationship between A and B. To know whether B is functional dependent on A or not, let's check that each value of A is associated with exactly one value of B. The A1 is associated with B1. Let's see if there is another A1 in this table. Actually, there is another one which is associated to B3, which means that if I gave you A1, you will not be able to decide the value of the B, because once it is B1 and in another time it's B3. So in this case, each value of A is not associated with exactly one value of B, because the A1 is once associated with B1 and once associated with B3. So in this case, A does not implies B and B is not functional dependent on A. Okay, let's check A and C. When it is A1, the value is C1. And when it is A1, the value is C1 as well. So in this case, if I give you the A, you will be able to get the unique value of C, which is associated to the A. If I gave you A1, you will able to return only one value of the C. So in this case, A implies C and C is functional dependent on A. Okay? Actually, the primary key in this relation is the attribute that implies all other things. Okay? The one that is associated with exactly one value of the other table. Let's see in this case, B1 is associated with C1 and A1. B2 with C2 and A2. B3, C1 and A1. Since that B is always unique, then B is the primary key. The primary key implies all attributes. All attributes should be functional dependent on the primary key. Okay? So the functional dependency is the relationship between the attributes. Okay? And we decide that B is functional dependent on A if each and every value of A is associated with only one value of B. Okay. What is the meaning of fully functional dependent? Okay. We say that X implies Y and Y is fully functional dependent on X if Y is not functional dependent on subset of X. Let's take an example. Assume that we have employee with SSN, name, together they are the primary key, and department and project. And it is stated that the department is dependent on name, which means that if I got the name of the employee, I can easily get the department. Okay? We want to know whether department is fully functional dependent on the primary key or not. Since department is dependent on a subset of the primary key, then it is not considered fully functional dependent. When the primary key is a composite key, which means that it has more than one attribute, okay, it could happen that one of the attributes is dependent on part of this key. So in this case, it is not fully functional dependent. In order to be fully functional dependent, we should decide the schema in a way such that each attribute other than the primary key is dependent on both of them. It cannot be retrieved with a subset. So in this case, we can say that the department is fully functional dependent. What is the prime attribute? It's the member of the candidate key, which means that name is a prime attribute, SSN is a prime attribute. So the prime attribute is a member of the candidate key. Okay? Let's solve some examples. Exercise number 1. The car dealer Omar would like to organize his inventory in relational database. The requirement analysis led to store info about each car that Omar converted into a relational schema. Immediately, he begins with collection of his old data and obtained the following relation car. Okay, so this is the table or the relational schema. The different car models are serial numbered model number. Okay, a model is defined with a manufacturer, the manufacturer number, okay, and the type and the engine power. Okay, for each model the vehicle number is unique. So for each model the vehicle number is unique. So together they can be selected as primary key. So in this case, the primary key is the vehicle number and the model number. After a while, Omar noted that he doesn't enjoy his database anymore. The data modeling seems not to be well thought. Describe the problems, redundancy, and anomalies that could occur if you use the above relational schema. In order to know what type of anomalies can happen in this case, let's take a look on the relational schema and see which two attributes are dependent on each other. If we look here, we will find that the manufacturer number and the manufacturer always dependent on each other. So we can deduce that manufacturer number implies the manufacturer. Okay? And that the type and the power always change together, which means that they are actually no, because this one is different, so it is they are not related to each other. However, if we check the model number, we will find that when it is 1, the power is 60. When it's 2, it's 90. When it's 3, it's 110. When it's 4, it's 90. 5, 105, 6, 60, which means that the model number, through the model number, we can get the power. Okay? Let's see what type of anomalies can happen. Actually, the 3 types of anomalies can take place in this case. Why? Let's start with the insertion. What if we want to insert a new model, okay, for which no vehicles are produced? Since the primary key is the model number and the vehicle number together, so there is no way to insert a record with a null value of any one of them. So in this case, if we have a new model, but we do not have a vehicle car yet, we cannot insert a record of the model number. So this is called the insertion anomaly. This is the first type of anomaly that will be introduced here. Let's check the update anomaly. What if that the information of the model number we want to update? Okay, so we change a model of 1, for example, to 5. Okay, if we do so without changing the power, then this will lead to data consistency because both of them are related to each other. So this is the update anomaly. Let's check the deletion. What if the car of a specific model are deleted? Okay, for example, we deleted model 1 and 2. In this case, we will lose the type. We will not have any record of this type. Okay? And if we deleted 2 and 3 as well, we will lose the manufacturer. We will lose all the data about Opel. So in this case, this is the deletion anomaly. Okay? Let's move forward. Given the following schema, which of the following functional dependency may apply to R? Let's start with the first one. A implies D. Let's check the A. When it is A1, we have D1. When it is A2, D3, A2, D2, A2, D3, which means that if I gave you the A2, you will not be able to get a unique value of the D because once it's D3 and in another time it's D2. So in this case, A does not imply the D. Let's check the other one. A and B together implies D. A1, B1 together have D1. A2, B2 together have D3. A2 and B1, D2. A2, B2, which is a repeated one, has a D3 as well, which means that whenever I gave you A2 and B2, you will be able to return a unique value of the D. So in this case, AB implies D. Let's check the other one. C implies E. C1, E1. C2, E1. C3, E1. When I gave you C4, in each time I gave you C4, you will be able to return the same unique value of the E. So in this case, C implies E. Let's check the E. It's always E1. However, in each time we get a different value of the A's. So this is not correct. In this case, when the A is repeated, A2, we will always get the same value of the E, which is A1. So this is true. A implies E. The last one, CD together implies B. Let's check it. This record will be repeated in any time? Actually, no. So in this case, without checking the B, this one will definitely imply the B. So this is true. Okay? Consider a relation which represents dentist-patient appointment data. The following describe the semantics of the relation. A patient is given an appointment at specific time and date with a dentist located in a particular room. Okay? So, the patient is identified by the date, time, and the dentist. Okay? On each day of patient appointment, a dentist is located to specific room. Okay? Let's extract or identify the dependencies from these two sentences. We stated that the time, date, and the dentist can get the patient. So if we have the app date, app time, and the dentist name or the staff number, we can get the patient. Okay? This is the first thing. The other one, the dentist in each appointment, on each day of a patient appointment. So we want the date. A dentist is located to specific room. So if we have the date and we have the dentist, which is the staff number, we can easily get the room. The other two things can be deduced, okay, by common sense. The staff number definitely will get the name. So if we have the staff number, we can easily get the dentist name. The same at the patient number at the patient date. If we have the patient number, we can get the patient name. Okay? Let's move forward. You decide to create a database track to track the songs of your favorite band plays in its live concert. Since you decide that the ER diagram are for kids, you decide to create a relation schema directly for your database. After much consideration, you believe that a single schema will serve. So we have concerts with city, venue, year, month, date, song, album. In this relation, the city, for example, Cairo, the venue, for example, Opera House, record where the concert took place. So together, we can know where the concert took place. The year, month, date, keep track of the time of the concert. The idea is that these 5 attributes uniquely specify the concert. So, all these attributes are the primary key. The attribute song, record the name of the song performed at a concert. You add album to record which album the song belongs to it. However, after using the database, you realize that your band have some characteristic that you should model in your database. Convert each of the next 4 sentences about the concert into a functional dependency. Consider each one independent. Okay? If you cannot write a functional dependency, say so and explain why. Do not assume any other constraint, even if they seem reasonable to you. Let's start with the first one. Each song appears in at most one album. In other words, the band does not repeat same song in different album. So if we have song and album, if I have song X, it should belong to only one album, for example, A1. If in the table there is another record of song X, it should always return, should always belong to the same album. So in this case, which one is dependent on which? Actually, the album is functional dependent on song. So if we have the song, we can easily get the album. Okay? Why? The opposite is not applicable in this case. Why we cannot that album? We cannot say that album implies song. Does it happen that we have a record if A1 that has a different song than X? Actually, yes, because the album can hold more than one song. So whenever I gave you the value of the album, you cannot return a unique value of song. So in this case, this one does not hold. The one that is correct, song implies album. B, a city does not have 2 venues with the same name. In other words, city and venue serve to identify the location of a concert uniquely. In order to know how to write the functional dependency of each one, let's take an example. A city does not have 2 venues with the same name. So if we have Cairo, opera, we cannot have Cairo and another opera, but we can have another venue, for example, must, because a city doesn't have 2 venues with the same name, but it can have 2 different venues. Is it possible to give you the city and you can return a unique value of the venue? Actually, no, because Cairo can have more than one venue with different names. Let's let's reverse it. What if we have opera here? Can we have a different city here? Actually, yes. It can happen that we have 2 venues with the same names but in different city. So whenever I gave you opera, you cannot get me a unique value of the city. So actually this one cannot be represented because city implies venue is not correct and venue implies city is also not correct. Okay? C. In an effort to please its fan, the band plays at most 1 song from any album in a given concert. Okay. In effort to please the fan, the band play at most 1 song from any album in a given concert. So if we have a concert, specific concert, okay, in this concert the band plays at most 1 song from any album. Okay, so if we have album X, and the concert, we can get the unique song that is played in this concert. However, if we have the song, can we get the album? Actually, no, because in this statement, it is not stated that a song cannot be repeated in different albums. So if, for example, if we have album A1 and album A2, we can have two songs with the same name. In C, it is not stated that we cannot have two songs with the same names in different albums. So if I gave you the song and the concert, you cannot deduce the album. However, the opposite can happen. If I give you the concert and the song, you can definitely get me the album, because in each concert only one song from this album is played. So for example, if we have concert 1 and song X, okay, and album A1, we cannot have another record with concert 1 and album and song Y with the same album, because only one song from the album is played. Okay, so in this case, the concert and the song together implies the album. What identifies a concert? Actually, the 5 attributes. So the 5 attributes, which is city, venue, year, month, date, and song, can get me the, actually the album can get me the song, because in this example, if we have the song, we cannot deduce it is from which album, because a song can be repeated. However, if we have here A1, which is the album, we can get the unique song of this album that is played in this concert. So if we have the song and if we have the album and the concert, we can get the unique song that is played in this case. Okay, in other words, we cannot have two records of the same album with different songs, because only one song is played in this concert of this album. Okay, the last example. The band plays in any city at most once every year. So actually, if we have the city and the year together, okay, we can have only one concert. In other words, if in Cairo 212 there is a concert 1, we cannot have Cairo 212 concert 2. This cannot be happen, because the band plays in any city at most once every year. Okay, so in this case, in each year and city together, we should have a unique value of a concert, only one concert in this case. Okay, so city and year together can get me the concert. How we can get the concert, or what is the thing that identify the concert? These 5 attributes. So it will be city, venue, year, month, date. However, when I say that city implies city, this is called a trivial dependency. So we can remove it, because this can be deduced without writing it. Okay, the same goes for year. We can also remove it, because this one is a trivial dependency. Okay, so the final answer would be city, year. Identified the remaining items of the primary key of the construct. Okay, which of the following functional dependency are consistent with the records in the above data? A implies CDE. Let's check the A when it is repeated. A, in this case it will be always Z, always W. However, the E will be changed, so this one does not hold. AB together implies the 3. When it is in each time, the AB will have a unique value, so in this case, this holds. BD implies C. BD together, BW implies the C, which is not correct because when it is B and W, once the value is Z and once it is R. So this one is not correct. So the only one that valid is this one. Attribute order ID uniquely determines order date. So order ID implies order date. Quantity fully depends on both order ID and product ID, which means that order ID and product ID implies quantity, both together. Okay? Now, order ID, product ID can get quantity and order date? Actually, yes, because the quantity can be deduced from both of them and the date can be get from the order ID. So this one holds. Order ID and product ID together comprise a candidate key? Actually, yes, because if we have both of them, we can get all other attributes. So this one also holds. Order ID and product ID implies order date show a partial functional dependency? Actually, yes, because the order ID is dependent on a subset of the primary key, which is the order ID, which means that order date is partial functional dependency on both of them. So in this case, all of the above. The last question. The following is an instance of the relation T, which has attributes A, B, C, D, E, F, G. Based on the above, indicate which of the following dependencies is a functional dependency or not. Okay? A implies B. Let's check the repeated value of A. 33 is repeated 2 times. Whenever it is repeated, we will have the same value of B, so this one holds. F implies G. F is repeated here and here. Whenever it's repeated, the G in this case will still 85. However, when it is 1, once the G will be 3 and once it will be 5. So whenever I give you 1, you cannot deduce a unique value of G, so this one is not correct. C and D together. Let's check the repeated rows. These two are repeated. So let's check the E in this case. It will always be 2001, so this holds. B implies A. The B is repeated here 2 times and here 2 times. Whenever the B is repeated here, the A will have a different value. So in this case, this does not hold. A implies F, G, C, D. We have to, this in order to be right, we must check that A implies F, A implies G, A implies C, A implies D. Okay? A implies F. When the A is repeated, the F will be the same. So this is correct. A implies G. When the A is repeated, the G will have the same value, so this is correct. A implies C. When the A is repeated here, the C will have the same value, so this is correct. The D, when the A is repeated here, it will always have 41, so this is correct. So this one is correct. H implies A. The H is repeated in this case in the last two rows. Whenever I have 98, I will not have a unique value of A, because once it is 77 and once it is 78, so in this case, this one does not hold. This was for today. See you next time, and thank you very much.